Hello, and welcome to another Making STEM Connections webinar. I'm excited to talk to you today about technology and the makerspace. What does it look like? What are the opportunities you have? And how do you use that in your learning environment? Based on that theme, I'm excited to share with you that we have a guest with us today. And this person is very familiar with our program as well as emerging technologies that are used in classrooms. So today we're going to hear from Celeste. Celeste has worked at the Science Center for a number of years in many capacities, one of them as a resident maker, but also as a person that worked with making STEM connections, both in the development and the implementation through professional development. And we are very, very excited to have her today. And she is going to share with you some of the new things that she has found out. She is in graduate school right now and focusing on technology and education. And she is going to share with you what she's doing there and some of the new things that she's finding out. So Celeste, can you talk to us about what you're doing in grad school? Where are you going to grad school? What is that you're studying, and what are some of those new and exciting things?
Yes, absolutely. So hello everybody. As Jolie said, I am in a graduate program right now. It's called Creative Technologies in Design, and this is at the University of Colorado Boulder. So this is a really interdisciplinary, awesome program, and it looks a little bit different for each person depending on what your professional interests are. But for me, it's all about the design of creative learning experiences, all aspects of it, from the fabrication of the physical tools that we use to learn, to the educational theory behind it, to, what are the new and emerging technologies that we can use in classrooms to help engage students. So one of the things that I've been doing is I've been working in this awesome lab called the Laboratory for Playful Computation. And the whole goal of the work in this lab is to help teachers integrate different disciplines that don't usually relate to one another, like science and art or engineering and music, and show how those subjects can be bridged by using computer science and cool new technologies. So one of the things that I've been doing is going into classrooms and using this tool called the MicroBit that I want to tell you about. And basically what the MicroBit is it's a tiny little super easy to program computer that lets you do a lot of really interesting things. So I'm just going to show you what it looks like. So this right here is the MicroBit. And you can see that it's just this tiny little square that's got a screen on it. Got a couple of buttons, and there's a lot of things going on with this guy. So there's sensors already built into this. This can sense temperature, it can tell what the altitude is, and the cool thing about it is that it's really easy to program. So right now I have it programmed so when I press a button, it's going to show a string of text that said SCI, Sci. If I shake it, it's going to show an icon. So I just want to show you how super easy this is to program. I'm going to pull this up on my computer. So this is all of the code for what I just showed you. So you can see right here that I have it, this little block right here is saying when I shake the MicroBit, show the heart icon. This little block right here is saying when I press the A button, show that string of text. So I'm going to change this to say my name. And this is how easy it is. After you change your code, you just press download. Add it to your MicroBit, and it's going to think about it for a second. And it's going to upload it. And now if I go back to my MicroBit, and I press this A button again, now it's showing my name. So the other thing about these is that they're really inexpensive. They're only about $12 each, and the BBC actually recently gave a MicroBit to every single student in the UK to help encourage students and teachers to play with computer science and to see how easy it can be to program things. So teachers are doing some really cool things with MicroBits in their classroom. I just want to show you one example really quick of something that you can do with this little MicroBit right here. So this is an art bot. You can see that there's a little colored pencil attached to it right here. And that easy to program MicroBit that I just showed you is attached to my ArtBot. So now, if I put this down here, it's programmed so that when I press buttons or when I shake the MicroBit, it's going to move around. So if I press this A button right here, it's going to move around and try to run off the table. Or if I shake it like this, it's going to do the same thing where it's going to try to run around and move off the table. So if I had this set down on a piece of paper, it could be making art. And when you do this in a classroom, basically what you can do is say, you know, let's experiment with different ways to make art through computer science and programming. So you can tinker with the types of materials that you're using. Maybe you're using markers, maybe you're using paint brushes and running this through paint. But the cool part is that you can integrate computer science and programming and new technology into that by using technologies like this. So some other cool uses of the MicroBit that I've seen recently in classrooms is you can actually get different sensors that attach to it, like sensors that sense the soil moisture level in your garden. So you could have students grow plants and attach their MicroBit to a sensor and have that sensor send information back to your computer about the health of that garden. And you could even take it a step further and have that data that you're getting from your garden about its health and its soil moisture levels, and you can use that to create an art piece that shows the health of your garden. So the reason that I think that the MicroBit is so cool is because there's so many different applications for it. You can use it in an environmental science class, you could use it in an art class, you could use it in a computer science class, and there is just a lot of different ways to use it, and it's very easy to get started with it.
So Celeste, I have a few questions for you. One is, can you talk to us, first of all, I noticed that the first MicroBit that you shared with us is plugged into your computer, but this one is not. So how does that work? How are you able to have this running without it being hooked up to the computer?
Yeah, that's a good question. So whenever you upload things to the MicroBit, it is saved onto this little MicroBit right here. So you can detach it from your computer and you can put it into something like this, and it will run the same program as long as it's attached to a power source. So this little MicroBit is actually very mobile if you just have some batteries connected to it. Like in this one right here, there's a little battery pack inside of this ArtBot.
Awesome. Another question about this is I noticed that you have like this special attachment that the MicroBit fits into. Is that something you have to purchase separately? Do other companies make something like that so that you could add it to a robot or something like that?
Yeah, so this is plugged into a little attachment right here. So there's my MicroBit that has my ArtBot code on it. And I can just stick it back in here. And this is actually called a MotoBit, this thing that I'm plugging it into, and that's what's controlling the wheels on my ArtBot. So there's different companies that make different sensors like this. If you have the Hummingbird kit from your Making STEM Connections kit, the new version of the Hummingbird kit actually has a spot for the MicroBit to plug in, so you can use that easy block-based MicroBit coding, and you can use some of the sensors that are on the MicroBit in coordination with your Hummingbird kit that you already have. I talked about garden sensors earlier. There's another thing kind of like what I have on the ArtBot where you just plug it in and it connects to, instead of having wheels, spots for motors on it, it has spots for soil moisture sensors and different things like a rain gauge or a different type of temperature sensor. There's a lot of different things like this that you can plug the MicroBit into to give it more capabilities.
Another question for you. I noticed that on the screen on your computer that it looks like it looks very similar to Scratch. Is that kind of how you use it? And is it challenging for students to learn this? What is the application of it?
Yeah, so if you've used Scratch, you'll notice that it's really similar to Scratch and that there's different blocks that you can drag out and use, like this on shake block right here, or show LEDs on the screen. And you can see from what I just did right there that it's super easy to get started with. You just have to drag blocks out there and put them on the screen. The other thing I'll say is that there's really good tutorials that go with this. So if you're feeling like you don't know how to teach coding to your students, that's not something that I would say you have to worry about when you're using something like the MicroBit, because there's a lot of really great resources out there already that tell you exactly what's going on with the code. And you can see right here, if I hover my mouse over it, it will show a message about what's going on with that specific block. The other cool thing about this coding environment is that you can actually switch over. This one's using a language called JavaScript, and you can see what the actual text coding looks like. So this is a good way to help students take it beyond, to go beyond this simple block-based coding and to start experimenting with this text-based coding that a lot of professional programmers use. In fact, JavaScript is a really, really common language that a lot of professional programmers use. So this is a really easy way to have your students experimenting with and trying out things that professionals actually use.
One more question, because I know that we've chatted about some of the amazing things that you get to do while you're in school, and you were sharing with us that you've got to meet a lot of people that are really on the forefront of this industry and tech and education. Is there anything you can share with us about that? What are people seeing as the future of this kind of technology in the classroom, and what does that look like for educators with technology changing as fast as it does? How do we keep up, or what are those things for us to look forward to?
Yeah, so I have had the opportunity to speak with a lot of different people, like Mitch Resnick, the person who is behind the invention of Scratch, spoke to one of my classes, and he had some really powerful messages to share about how important computer science and programming really is for our students. You know, they're talking about how computer science and programming are a new basic literacy. If you want your students to be capable creators and not just consumers of media, they need to be able to program. And that sounds a little bit intimidating, but there are so many great resources out there, like the one that I just showed you, this MicroBit coding environment. I know Jolie is going to talk about some other resources that are out there. And he really emphasized that your job is not to be the expert on computer programming. You don't have to know an entire coding language to be able to support your students. What's really important is that you know how to help your students problem solve and how to help them work past these spots when they get stuck. So that might just look like sitting down with your students and saying, let's look up some resources to figure out how to do this ArtBot programming that you want to do. The other thing that I will say is that I think that there's this big shift in seeing computer science and programming not as this, boring typing words onto a screen, very technical thing. Now there's a lot of opportunities to see computer science and programming as a creative expression. So there's all kinds of things out there that let you use computer science and programming to make art and to make music and to create your own technologies and tools. So I would really encourage any of you to ask questions, to dig a little bit deeper, and also to keep an eye on the Facebook group, because I try to share when I find new technologies like the ArtBot and the MicroBit that I just showed you. I try to share those things and tell you about why I think it's cool and different ways to use it. So that might be a really good place to start.
Awesome. Thank you so much, Celeste. Love having a guest speaker. We look forward to anything else Celeste has to share with us as she learns more things while she's in school. So thank you so much. So based on those things that Celeste shared with us, we're going to continue with our webinar talking about technology in the makerspace and look at what some of those options are. How do you bring technology into your space, whether that space is in a classroom, whether it's a dedicated makerspace, whether it's a traveling set of materials. So we're going to take some time now to look at what does technology look like in the makerspace. And something I think that Celeste touched on, which I think is really great, is this idea of don't fear technology, learn technology. And it's going to be more and more challenging as time goes on because the technology is changing so fast, it's difficult to keep up with it. But we still can embrace that in our educational opportunities and the experiences that we provide for our students, because those will be imperative as they not only continue in the educational system, but as they move beyond into their careers and their application and use of technology and the jobs that they have. So don't fear technology, learn technology. An example of something that I would like to share with you is something that I made using the Hummingbird kit, which is something called a Lightbox, and it's based on colored shadows and LED lights. So what you see here is the front of the box, and I took just a regular cardboard box. I cut out a panel in the front and put a piece of parchment paper. So the same parchment paper that we used for doing our plastic fusing. So this is what it looks like from the front, the same box, but let me show you what it looks like from inside the box. So what I did is I added lots of different pieces that would either refract, reflect light, change the way the light looks, change the colors. So you will see that, for example, here's a hummingbird motor that's down here, and I have a little platform with a plastic cup on it. And once you turn the motor, then this cup moves, and then the light, as it's projected through that, puts an image onto the screen, onto the parchment paper. Then you will see also these other different hanging lights. So through the Hummingbird kit, for example, the tricolor LED light, I can code for this light to change color, and I can also code for the motor to change speed. So it'll provide a different image that's projected onto that parchment paper. And then you see lots of other little pieces, doodads, aluminum foil. I have some Christmas ornaments and different things that are hanging through there that provide that image. And it's been really fun to make these, and students can put different components in there, change it in different ways. You could use flashlights with this, but it's just really an exciting way to look at the Lightbox. Some other examples of technology that I wanted to share with you is coming from Jay Jackson, who's at Clarion Goldfield Dow's Middle School, and he is really big on doing Rube Goldberg machines. And so here are some ways that he's been adding motors. So right here in this image, what you see is there's a DC motor, which you got in your kit. You got 30 of those, and he's got his students have set up some type of cord or rope to the motor, and down here is a button. So when this is pressed through the Rube Goldberg action, then that starts the circuit, that completes the circuit. Here's the battery, which causes the motor to turn, which then translate into the next step. And here there's something similar, that there's a trigger release for a car to go down the ramp, hit this rubber ducky, which then drops into the basketball net. And all of that is controlled through various circuitry components that come in the kit. Here are some other pieces that you can see of ways that he's been incorporating these forms of technology. He's really great at using these DC motors in lots of different ways and hooking up different attachments to it. This machine right here was designed to dunk an Oreo into milk as a part of the actions, and these are pictures that his students took and labeled and sent to us so we could see these different technologies and how he's using them. A book that I highly recommend for you if you're going to be incorporating different types of technology and circuitry and gadgets and things in your classroom is this book called Unscrewed. And Ed Sobey, what he did is he went through and found a lot of technologies for you to deconstruct. So things like answering machines or hair dryers, And you can take those apart and harvest different materials. So in the book for each section on that piece of technology or equipment, he tells you what are those things that you can harvest, and he gives it a score. So he tells you how valuable those things are and how those could be reused for something else. So he gives you directions on that, but also shares with you some of the challenges, some of the dangerous things. If there's capacitors that are in there, how do you dispose of those, and how are you careful with them? But I love this quote that comes from the beginning of the book. Let's go on a treasure hunt. Let's plunder old gizmos and gadgets for the good parts inside. If you are curious, if you want to know what's on the inside of that plastic or metal case, if you like to know how things work, this hunt is for you. And he gives you just really great directions to explore the digital world, not just in coding, but actually in deconstruction of those pieces and learn how they work so they're less of a mystery. We had workshops like this at the Science Center in our makerspace, and you can see some students here that are doing some deconstruction. Things like fax machines are really great to take apart. Sometimes kitchen equipment that isn't being used anymore. There's amazing things that you can find. So oftentimes in making, we talk about building, but unbuilding can actually be very powerful as well. You can learn a lot about machines and how they work by deconstructing them and taking them apart, and it becomes less of a mystery, less magic, and more knowledge about how these things work. You can also harvest pieces from them, LED lights, fan parts, wires, motherboards, things like that, gears, switches, lots of things that could be reused for other purposes. Another really exciting thing that you can try is circuit bending. So circuit bending is the way that you alter the way that circuit is being used. So this is a tape player, a personal cassette player. If you think back to your old Sony Walkman, that's what this is, with the lid taken off, and we see the batteries that are here. And there's a tape in there, and then when you push on the button to play it, it's hooked up to speakers. This student is connecting through the alligator clips different parts of the board and causing the sound or the speed of the tape to play differently. So he's bending the circuit. He's shorting the circuit on purpose to create different sounds. And it's all just run off of, you see the AA battery, so he's not going to hurt himself. He's not going to create a type of electrical fire by experimenting with the electrical path that is traveling through this machine. So circuit bending is also really exciting. You can add things like a switch or a potentiometer, which you got in your Hummingbird kit, if you have one of those. And a potentiometer is a dial that controls the amount of that current that's flowing through. So it's similar to a volume button. So you can turn it and change how much or how fast or how long or how bright something is shining. So there's lots of ways you can manipulate things that otherwise might be thrown away or discarded. There's a world of investigation that can be done. It's a dissection of electrical components instead of maybe a typical biological dissection that you may have tried before. So let's look at some things to keep in mind as you are designing technology to have in your makerspace. So here's 5 things. Last time we talked about 5 things to keep in mind as you design your makerspace. This time we're going to look at 5 things to keep in mind when including technology in your makerspace. First of all, have some type of computer that you can use for programming in some capacity. So here's a list of some examples of different programs like Scratch, as Celeste was talking about. The great thing about Scratch is that it is browser-based, so you don't have to download it. Scratch Junior, which works on iPads and really introduces you, I'm going to show you a picture of that here in a minute, to the drag and drop programming of Scratch. Code.org is a really great place for students to begin that process. Khan Academy, I personally use Khan Academy to begin teaching myself code. And Khan Academy is definitely designed for older students, so even your students could be using that. They have lots of options, lots of courses that you can take on Khan Academy for learning code, but also the application of that code. And students can watch that on their own through their device, their Chromebook, laptop, computer, whatever else they might have. So they begin to become more comfortable with and empowered by that. Something else that I use that I was going to show you on my phone are apps. So there are lots of apps as well for learning how to code. So I have actually here, there's a whole load of them called Solo Learn here, and this is just in the App Store. I'm just showing this to you that you can find these kind of things on your phone. But Solo Learn has multiple languages that you can do. So I have it for Python, I have it for JavaScript, and I have it on my cell phone. And it has classes that you can take, little activities that you can do. And once you've passed it, that level, you move on to the next level for coding, and you become more and more confident in that, and you build upon it. So when you're sitting at the doctor's office, instead of checking your Facebook feed, maybe you can do a little bit of work on your coding knowledge. Students could do the same thing too. So if they have an iPad or their smartphone, they could also download these kind of apps and begin to learn that kind of code. The coding platform that Celeste was talking about earlier, Scratch was designed for children. It was designed for them to be easily able to manipulate it and learn how to use it, this block-based programming, this drag and drop programming. And it works well with your Hummingbird kit if you got that. But even if you don't have the Hummingbird kit, Scratch is a great forum for students to begin that process and expand it. Something that you can add to Scratch programming is your Makey. So you could hook up the Makey to your laptop, to your computer through the USB port, and you can have input from the Makey trigger something to happen in your Scratch platform. So maybe the sprite jumps up and down whenever the circuit is completed, or the sprite says meow, whenever this circuit is completed. So you could have multiple circuits working off of your Makey and connect that to your Scratch programming. Something I wanted to point out over here, that if you have the Hummingbird kit, there is a version of Scratch, we showed you this at the training, that will allow you to integrate the components of the Hummingbird kit with the Scratch. To do this, though, you have to download this off-site or offline editor of this version of Scratch. So you would have to download it. And the directions for how to do that are both on the Hummingbird website. And I can share those with you too if you need them. But then once you download it as an offline editor, you can build it and save it, and then you can upload it to share with other people. But the key is that's how you get this More Blocks tab. And those are all the blocks that come with the Hummingbird. Here is an example of what Scratch Junior looks like. We have this book over here. I use this when I work with younger teachers of younger students to help them to learn how to use Scratch Junior. But this is what it looks like on an iPad, and you see these are the sprites, a little bit different than the regular version of Scratch, which has a cat sprite, but you can select these different sprites similar to the other version. And the drag and drop programming is similar, but there's not words. So there's visual cues, so arrows or actions that you can see here, and then you drag and drop and click those together in order to get the different sprites on the screen to do whatever that action is. And you can change the backdrop. You can actually, with your iPad, you could take a picture of your classroom and you can have that be your background, and then you can have the sprites interacting even within that classroom setting. Something to think about, as Celeste was sharing with us, is the importance of coding and programming. And I know that for many of us, this is a realm that we're very new to, that it is not something we were trained in our educational training and in becoming a teacher. We would call ourselves digital immigrants, that we didn't grow up in a world that had iPads or even cell phones for some of us. But the students today in the educational system have grown up with this, and this is the world that they know and they're used to. And we want to provide them opportunities to use that technology, not just for things like Snapchat or YouTube, but also to build and create with it. And those opportunities can lead to careers that are involved in computer technology. So some work that code.org did looking at Iowa, you see that Iowa has a very large demand for jobs that are involved in computer science. but we're not putting out very many students with those kinds of degrees. So there's a gap. There's a large gap in what's available and what we as a state are able to produce. You see that computing occupations in Iowa have an average higher starting salary than others. We also see it, which is a great motivation for students to see that as an option for them. But also notice that there's, not only do we have very few computer science graduates, if you see 380 computer science graduates in the state of Iowa in 2014, and only 16% of those were female. So it is on us as educators to help students, first of all, to see the importance of computer science in their lives, but also see that as an option for a career or a study path, and helping students of all, coming from all different kinds of backgrounds, to see how computer science can be something that they use, that they investigate, and that they adapt, even if they don't follow computer science as a degree, but that computer science can be embedded in the work that they do. As Celeste was sharing, artists are using these kinds of products now, coding and technology products. We're seeing it in music and lots of other fields as well. It's also important, number two, to make technology accessible to students. We don't want to just hide it from them or say this could be broken or this might be dangerous for them. We need to make it accessible to them. So not every student in every school has access to everything that they possibly need. You may only have one or two of something. The Hummingbird kit, for example, the Cubelets, there's not enough for everybody, so maybe you need a sign-up system or a checkout system that allows students to have access to those. Work-appropriate spaces for children, lower tables, being able to put a type of laptop on there or some type of computer that they can have access to, and setting up ways to make it safe for them to use that. So there are lots of systems that can prevent students from going on to internet websites that are not safe, or even limiting what they can do on the computer, but still making it accessible to them. We don't want to put barriers that say, well, students can't because they might. Let's say students could if we were able to. Let's look at it that way to provide those kind of opportunities. So here's an example of a classroom. What I like is there's lots of open table space. There is a designated computer desk, but there are definitely opportunities for those spaces to be used in lots of technology opportunities. We see in this lower right-hand corner in this table that there's some Ozobots and other types of light tracing robotics that can be used in that space. We see power strips on top of the table so that they can access them. This is not a room that was designed to be a tech room, but it certainly could be modified to support that. Let's remember too that technology doesn't always have to be something that's plugged in. It doesn't always have to mean coding. Technology is a tool. It doesn't have to be electrical. It could be very low tech in that sense. And I wanted to show you an example of a picture of something that our resident makers made one summer, and I absolutely loved it. It's a music box. And what you see here in the picture are bobby pins. So these are hair pins, bobby pins, and you see a dowel with a handle, and then this is a cardboard tube that has different fasteners or brads, as we call them. And those brads are embedded in this tube in a very specific pattern. And the idea is that when you turn this crank here, that it will turn this drum or this barrel, which will then hit each one of these bobby pins here. And these will vibrate and create a sound based on the length of that bobby pin where it's stapled down here. So they created basically their own music box, which really, in a sense, is code, because the song that this music box played is based on the code that's embedded here in the drum. So it's a very low-tech way to include technology and code and music all together. Sometimes we have a lot of technologies that we don't realize that we have access to. So maybe even doing a survey in your organization, in your school, to find out what do we have, what can we use, what do we have access to. It might be something that older students use. It could be something that is in a specific classroom that maybe you could have access to. Bring it into your classroom. But first of all, find out, do you have a 3D printer in your district? Do you have one in your building? Do you have access to it? Are you comfortable using it? Is there a local business that can allow you to use materials? Sometimes they have extras, or they have outdated versions that they no longer use, which might be useful to your classroom. Can you go on a field trip? Could you take products with you and use at a local business? Could you use their technology in order to complete a project or a component? And could older students in the district get involved? Could you have friends from the older grades bring down to your classroom or to your school or somewhere else in your building the materials to do more high-tech activities? Something I've been seeing a lot as I travel around to schools and even across the country is this resurgence of technology spaces, industrial technology spaces. So sometimes it might be a space or a room that's not being used anymore. And that could bring more access to technology. And this is one I want you to really think about too, is this idea of having a dream. Think about, what are those new technologies that are out there? Are you interested in microbits? Is that something you want to look at? Keep a list of these things. What are you hearing from different conferences or other teachers sharing with you? How about on the Facebook page? You can share with us new things that you've tried or questions that you have of things that, ways that you're using current technology. I love it when people go to conferences and they come back and say, I found out about this, we saw examples of, I want to see if there's a way that I can. So always have a dream list. What are those new components and pieces? And then once you have that dream list, then you can start looking for funding. So you could find out who in our school district could support this. Is there a budget for it? Are there grant opportunities for us? And use your Making STEM Connection Award to be a stepping stone in that. You could say, we have one set of Cubelets, we would like to get more. Or we have a Hummingbird kit, but we'd like to get microbits that could be used with them. And in your grant writing opportunities or processes, you could kind of leverage the award that you've already received to maybe get more. So a few things to think about with 3D printers. I hear a lot of schools that have 3D printers and many teachers who have either no access or no idea on how to use them. And I think that's a challenge that we need to face. We need to become more educated in how to use 3D printers, what they can be used for. And that I love this statement from Wired Magazine, that this editor-in-chief believes that 3D printing will be bigger than the web. That this is the future of technology and things that we need, that we want to make, that we want to fabricate, that we want to prototype, that we want to create, is in 3D printing that. We could 3D print food. We can 3D print organs and tissues. We can 3D print structural components, such as building a house. That future thinking with a 3D printer is, I can design it on some type of technology like using a program, a software, but then this machine can bring that to life. It can translate it into a tangible object. And all we have to do is supply the material. What is the filament? And that filament can vary depending on what you're trying to make or what you're trying to create. I've seen 3D printed pottery. So there's a type of clay that comes out of the extruder based on the code that is being used, or the program of how it was designed. Lots of other ways that 3D printers can be used, as we were sharing in healthcare. I've seen it in fashion and design, that designers are 3D printing components for their designer lines, and it could be accessories, but it could also be pieces directly used in the textile itself. Lots of personal applications of people needing something in their home, needing a component or a tool. They can design it and then 3D print it I've seen it used in the automobile industry. So there's a part that's not made for a car anymore, and they can 3D print a version of it, or they can 3D print a model of it that could then be used to create a cast of that component in a different material, like a metal, steel, aluminum, whatever it might be that's necessary for that car. So I have a lot of people who ask about what kind of 3D printer do I get, and there's lots and lots of options. And I don't know, Miss Celeste, are you still mic'd up?
I am.
Okay. How about, since we still have Celeste here, I know Celeste has worked a lot with 3D printers. Do you have any thoughts that you want to share maybe about what are some things that teachers can look for in 3D printers, or how do they go about that process of beginning to shop for or look for a 3D printer?
Yeah, that's a great question. So I think one of the biggest things that I would look for if you're thinking about integrating 3D printing into your classroom is picking a 3D printer that has software that is easy to use for your students. So for example, at the Science Center, we have a brand called MakerBot, and that comes with software that's really easy to use. And I know there's a couple other brands out there that also have really easy to use software, but that's important because, you know, it's hard enough figuring out how to make your 3D model and going through that whole design process. So you want to make the actual printing of the object as easy as possible. The other thing that I would look for is you probably don't want the cheapest 3D printer that you can find, because, you know, while that's going to make it more accessible and easier to fund, that's going to limit what you can make. So some of the cheaper 3D printers, it's a lot more difficult to print complex structures. They break down. They don't have universal filament systems, so the type of materials that you use in your 3D printer might not be the same. So I would look for something that's kind of in the mid-range of, you know, cheap and affordable, but also not going to break down immediately and has good support. So that might be a good place to start. The other thing I would recommend is that Jolie had a link on the slide that she just shared that has this really nice comparison. And it shows you a bunch of different brands of 3D printers, how much they cost, you know, what type of software they use. And that might be a good place to start, because you can start looking through those different categories and think to yourself, you know, what's going to fit into my funding limits, or, you know, what type of filaments do I want to be able to use? And that's something that we can get into later and talk about more in depth, but that's another consideration as well, is what type of materials do you want to be able to 3D print with? Just regular plastic, or do you want to be able to use fun, flexible stuff? Because not all 3D printers can use the same materials.
Thank you, Celeste, for sharing that. She has lots of knowledge and experience on using 3D printers. So I'm glad that she was here today to comment on that. The link that she was referencing that's in the PowerPoint here, that I will copy and paste that, and I can send it to you in an email, because I know it's a long one. And each one of those numbers that you see there is a different example of a 3D printer, and they go through in this article, and they go through and kind of compare and contrast. So I know that's a lot for you to write down, but I'll send it to you. I'll send it in an email with some other information if you would like to look at that. Here's a picture too about the MicroBit that Celeste was talking to us about before. Think about this in your dream plan. Is a MicroBit something that you could maybe use? One of the things I really, really enjoy about that, when Celeste and I first started looking at them, is they're extremely affordable. You just have to be able to plug it into a USB port. It doesn't require a separate power source besides that, at least for your basic coding. If you want to detach it, as she was sharing with us, and add it to other things, it might need a power source, but it's a really easy way you could have to begin looking at coding. Lots of students at that price point, lots of students could have access to it. You could have a classroom set. There could be an opportunity to write a grant for that, maybe even PTA or PTO funding to get a set of microbits that could be used at your school. And it's, again, a really great entry point, and you can add things to it. So you could expand on it. And once the students have those kinds of experiences, they begin thinking about, what if we used it for this? Could we do this with it? Could we add something that would? And that's exactly the kind of thinking we're looking at, that computational thinking, that problem solving, and they will begin to develop that the more experiences that they have with that kind of technology. So we want them to be empowered by the technology, not just use it as an app. Apps can be great, but why not make your own app? And I'm going to show you a video here in a little bit of a young man who took that challenge literally and started making his own apps. But what are ways that we can use technology to create and make various things? Some ways that 3D printers can be used in education. Oftentimes we can print pieces like what we shared with you at the training for the make-do kits, the hinges or the L brackets. You could certainly print things like that. But students can begin to design their own projects and different things that could be printed. This student you see in this picture has 3D printed different components of a manipulative or a hand that can move, that has the various attachments so you can simulate the actions of the hand or the fingers closing. So imagine how they can learn and begin to understand how the human body works based on 3D printed versions of those. You can use 3D printers to have to create three-dimensional visual aids. I spoke with an instructor at Drake University, and he 3D prints versions of molecules, especially enzymes, and then the molecules that those enzymes break down, so that he can show those in his classroom setting. So these are large-scale versions of a molecule, and you can look at things like active sites and how the enzyme is able to recognize which protein it's going to break down, or what happens if something degrades or denatures that protein. He can show that all by modeling it with these 3D printed versions of the proteins. So that idea of three-dimensional visual aids are really powerful for students, especially when you can create them in whatever version it is that you want to use or to focus on. They make it easy for teachers and students to really take those ideas of something they want, something they need, something they have an idea about, and create it and make it. And I've seen people come up with lots of things based on lots of trial and error with 3D printing as well. And sometimes that in itself is the challenge. They might have a great design, but if they didn't set it up right in Tinkercad and the pieces don't connect right, then your print might not come out the way that you expected it to. Or the different supports that you need as you're printing it, or if you're using more than one type of filament or what kind of filament you use, those are all great opportunities to work through problem solving and to come up with what is that product that you're looking for? What is your, how do you go through those stages of design and build? So exactly here, this idea of being able to make an object that they need to complete their project. They need something that will connect these two pieces together, something that will hold this other object connected to it, something to support the weight of this. They could design it and then print it in the classroom. Or it could print while they're not there, knowing that sometimes 3D printers are a little noisy or they can be a little testy, but still the idea that they can design and print something that they have designed or created. I love this example of the bridge that you could 3D print different components that they could then prototype different designs. So imagine if they prototype it in filament form, then they could build it later out of another material that maybe can hold more weight or has different properties. But this is a very quick and easy way for them to try out some of their design plans. And we talked a little bit about the Hummingbird kit as well, and how to use Hummingbird with Scratch programming. There's other programming. You can use Snap programming with it too as well. You can use its own Create Lab Visual Programmer. But I wanted to show you an example. We're going to watch some video here of some 8th grade students that used Scratch and Hummingbird materials together. And something for you to think about as you're looking through this is, how did they interface tangible pieces with the Hummingbird kit and the program that they coded for on Scratch through their computer. So the interface between those two, I think, is pretty amazing. Here's a video of Cubelets being used, and what they did is, so remember how Celeste shared with you the pen being attached to the robot that she had with the wheels? So this is someone who attached a marker to the Cubelet robot and then started it, and then you can see how it is drawing that way. Bot with the different, there's no sound on this one, with the different Cubelet components. Here is the young man that I was telling you about earlier. And this is Tomas Suarez, and he is actually an adult now. This was taken a few years ago, this TED Talk that he did, and he is a computer programmer. But I love this, what he brings to us. He's a 6th grader in this video, and he brings to us that realization that we oftentimes think that kids might be too young, or they can't, or they don't have the ability to, or we don't have the equipment that allows. And we put sometimes barriers, not only for ourselves, but sometimes for our students, and think that that's maybe not possible. And what I love is Tomas's ability that he shares with us in this TED Talk to really think beyond that. And he had an idea and he wanted to try it, and how did he move forward with that idea? So this is Tomas Suarez, and he's talking to us about writing his own apps using his iPad.
Hello everyone, my name is Tomas Juarez. I've always had a fascination for computers and technology, and I made a few apps for the iPhone, iPod Touch, and iPad. I'd like to share a couple with you today. My first app was a unique fortune teller called Earth Fortune that would display different colors of Earth depending on what your fortune was. My favorite and most successful app is Bustin' Jeeber, which is a Justin Bieber whack-a-mole. I created it because a lot of people at school disliked Justin Bieber a little bit, so I decided to make the app. So I went to work programming it, and I released it just before the holidays in 2010. A lot of people ask me, how did I make these? A lot of times it's because the person who asked the question wants to make an app also. A lot of kids these days like to play games, but now they want to make them. And it's difficult because not many kids know where to go to find out how to make a program. I mean, for soccer, you could go to a soccer team. For violin, you could get lessons for a violin. But what if you want to make an app? And the kids' parents might have done some of these things when they were young, but not many parents have written apps. Where do you go to find out how to make an app? Well, this is how I approached it. This is what I did. First of all, I've been programming in multiple other programming languages to get the basics down, such as Python, C, Java, etc. And then Apple released the iPhone, and with it, the iPhone Software Development Kit. And the Software Development Kit is a suite of tools for creating and programming an iPhone app. This opened up a whole new world of possibilities for me. And after playing with the Software Development Kit a little bit, I made a couple apps. I made some test apps. One of them happened to be Earth Fortune, and I was ready to put Earth Fortune on the App Store. And so I persuaded my parents to pay the $99 fee to be able to put my apps on the App Store. They agreed, and now I have apps on the App Store. I've gotten a lot of interest and encouragement from my family, friends, teachers, and even people at the Apple Store, and that's been a huge help to me. I've got a lot of inspiration from Steve Jobs. I started an app club at school, and a teacher at my school is kindly sponsoring my app club. Any student at my school can come and learn how to design an app. This is so I can share my experiences with others. There's these programs called the iPad Pilot Program, and some districts have them. I'm fortunate enough to be part of one. A big challenge is, how should the iPads be used and what apps should we put on the iPads? So we're getting feedback from teachers at the school to see what kind of apps they'd like. When we design the app and we sell it, it will be free to local districts and other districts that we sell to. All the money from that will go into the local ed foundations. These days, students usually know a little bit more than teachers with the technology. So, sorry. So this is a resource to teachers, and educators should recognize this resource and make good use of it. I'd like to finish up by saying what I'd like to do in the future. First of all, I'd like to create more apps, more games. I'm working with a third-party company to make an app. I'd like to get into Android programming and development. And I'd like to continue my app club and find other ways for students to share knowledge with others. Thank you.
So I just really love his message in that, based on something that he was interested in. He wanted to figure it out, and he did. And the application of that was making and creating his own apps. And I think sometimes we think it's so mysterious how these things come about, but he took the initiative, did some research, and figured out how he could make those himself. And it really wasn't as difficult as he thought it was. So how amazing that a 6th grader was making his own apps and then putting them on the App Store. What a great example of being a maker and having entrepreneurial thinking. A few other things I wanted to share with you, other resources. We always reference the Makerspace playbook in our trainings, in our webinars here, and you will find some great information in here on page 35 and 39, about 35 through 39, about using technology in the classroom in a learning setting. That's a great resource. It's a free download. The book that you received as part of your kit, Invent to Learn, there's lots of information in here on how to use technology. One of the people, really one of the focuses they have in here is Seymour Papert, and his belief in using technology as an educational tool. And what's amazing when you read about Seymour Papert in the first chapter is that in the 70s, he was already coming up with ways for students to use computers in the classroom. The 1970s. Okay, so think about that. We were still figuring out how to send men to the moon at that time. So you can think about the size of a computer. They weren't personal computers. They weren't laptop computers. But he was recognizing the future of America needed people who knew how to use those computers. And he knew they would get smaller. He knew they would have more adaptations to them to make them more user-friendly. So he was already devising ways to use computers in the classrooms back then. So he really was kind of the frontier here in the United States of using computers in the classroom. So the book focuses a lot of things about here, really speaks to a lot of what he was working with fundamentally with students and as well as graduate students at MIT. And you see there are lots of things that you can find in Chapter 7, the game changers of this book, Invent to Learn, that will help you with understanding 3D printers and fabrication, physical computing with things like Raspberry Pi and Arduinos. Those are great, maybe second or third steps after things like a MicroBit. Your Hummingbird kit is a modified Arduino. That Hummingbird board is a modified Arduino. Arduinos use a coding language. So as students become more familiar with things like JavaScript, if you're using the MicroBit, then they can learn more about how to code the Arduinos. And Raspberry Pis have incredible applications. It's very similar to what you saw with the MicroBit, where you can code it to do certain things. It's like a mini computer. And then as long as it's hooked up to a power source, it can do whatever that action is that you coded it to do. It also talks a little bit in there about languages. And I think it's really interesting for students to be thinking about coding languages. In the United States, we look at things like foreign languages, things like Spanish or French, Japanese or German, but are we really looking at coding languages? Is that something that we can add to our educational experiences for the students that we work with? And you'll see a lot of support for that in this book. The Art of Tinkering, which is another book that you received with your kit, has some great examples of using technology in many ways. You'll see on pages 82 to 89, there's some information there on sewable circuits, wondrous wearables. The materials that we gave you in the kit will certainly get you started on doing simple circuits, but you can actually purchase codable components. They're like Arduinos through the same company that makes the components that you got, and they can code. So you can tell it to code, or you can code for it through the computer and tell it, if the light sensor does this, then have this action. Just like the kind of things you were doing with the MicroBit, but then you can adapt it to work with the LED lights and other components that you might have that are sewn into a textile. So anyway, you see lots of things there, lots of examples of using technology. And I do have another video that I'd like to share with you. They talk about things like Rube Goldberg machines, as we saw, that are being used in Clarion, incorporating technology. So I have a little music video that I would like to show you. It's one of my favorites, and it's by a group called OK Go. And if you enjoy this video, I encourage you to find more of their music videos, because they love to embed technology and science in their music videos. So it's amazing just to see what is happening in the video as well. So I'm going to show you this one. The song is called This Too Should Pass, and it's basically a giant Rube Goldberg machine. So I love that video. I think it's amazing. I think it's a great opportunity to talk about things like potential energy and kinetic energy. I also think it's a great opportunity to look at teamwork. You saw those students at the end that helped them to set that up, and how many times did they have to set that up? How many TVs got busted? How many times did they get squirted with paint? So it's really a great example of that kind of thinking. And if you enjoyed that, I encourage you to look at some of their other videos that are very scientifically based, lots of really interesting music that they make, but also their videos, they spend a huge amount of time in preparation of those videos. So just a reminder that we have one more webinar left in our series. Our last one will be focusing on the challenges and outcomes of maker education. So, you know, what are the pieces that we use? How do we assess it? How do we get parents involved? How do we keep keep new things being brought into the space? How do we set up the space? How do we transition it? All of those kinds of challenges that we face in maker education, because it doesn't look like a typical classroom. It looks very different. So those are the kind of things we'll be looking at next time. And I encourage you, if you have any questions, to let us know. If you have any stories that you want to share, remember, sometimes even something not working is a great story to share. You can share that with me through email, but you can also do it through the Facebook page if you like to use that. As Celeste was mentioning earlier, she likes to post things on there, great examples of things that people are trying or using, questions that you have. That's really a platform for all of you to share and learn from each other. So I look forward to hearing from you, and between now and our next webinar with any questions or concerns, and we'll see you again in a few weeks. Thank you. Happy making.